طبعاً عزیزم کاتتان باش. ئەمڕۆ دێنە سەر بابەتێکی تازە واتە بابەتی فیزیای تەنی ڕق Introduction to Solid State Physics. دەست پێ دەکەین بە چەپتەر 1 چەپتەر 1 Introduction دەبێ واتە پێشەکی. Solid state physics is the study of solid matter through methods such as quantum mechanics, crystallography, electromagnetism, and metallurgy. The branch of physics concerned with experimental and theoretical investigations of the properties of solids, such as superconductivity, photoconductivity, and ferromagnetism. It is the largest branch of condensed matter physics or material science. So, solid-state physics forms the theoretical basis of material science. It also has direct applications to technology. Condensed matter physics is the field of physics that deals with the macroscopic and microscopic physical properties of matter. It is concerned with the condensed phases of matter. Condensed phases are solids and liquids, which arise from the electromagnetic forces between atoms. Condensed matter physicists try to understand the behavior of these phases by using physical laws. They include the laws of quantum mechanics, electromagnetism, and statistical mechanics. Why study solid-state physics? The aim of study of solid-state physics is to try to understand how the macroscopic properties of solids result from their microscopic atomic scale properties. The important motivation for the study of solid-state physics is the fact that the microscopic properties it deals with are responsible for the majority of modern technology. These properties determine the mechanical strength of materials, how they interact with light, how they conduct electricity, and so on. So, solid-state physics is an important subject for technology because it gives guidance on how to design the circuits needed for modern electronic devices. This field gave us both the transistor and the semiconductor chip. For this reason, solid-state physics has been linked to material science, chemistry, and engineering. Recently, it has also linked with biology, biochemistry, biotechnology, and medicine. Phases, matter, anything in nature occupy a space which has weight and volume. States of matter. Solids, definite volume, definite shape. Liquids, definite volume, no fixed shape, flows. Gases, no definite volume, no definite shape, takes the volume and shape of its container. Plasma, fourth state of matter, no definite volume, no definite shape, composed of electrically charged particles. Condensate, fifth state of matter obtained when atoms or molecules are at very low temperature and their motion is stopped. Element, one type of atoms. Compound, two or more different atoms chemically joined. Mixture, two or more different atoms combined. Characteristic properties of solid state. Solids have definite mass, volume, and shape. Solids are incompressible and rigid. In solids, intermolecular distances are very short. In solids, intermolecular forces are very strong. The particles of solids have fixed positions. Classification of solids. Solids can be classified into types on the basis of the arrangement of their constituent. Particles, atoms, molecules, or ions. These two types are crystalline solid and amorphous solid. Solids have large number of crystals, which with defined geometrical shape are called crystalline solids. The particles of crystalline solids are arranged in regular pattern, which is repeated periodically over the entire crystal. Crystalline solids are anisotropic in nature. That is to say, many physical properties such as electrical resistance, refractive index, etc. are different along different axes. Example, NaCl, quartz, ice, HCl, iron. Characteristics of crystalline solid. Crystalline solids have definite characteristic geometrical shape. Crystalline solids have sharp characteristic melting point. Crystalline solids have definite and characteristic heat of fusion. Crystalline solids produce pieces with plain and smooth surface when cut with a tool of sharp edge. Crystalline solids are anisotropic in nature. Crystalline solids are true solids. Constituent particles of crystalline solids are arranged in long-range order. Amorphous solid. Solids having irregular shape of particles are known as amorphous solids. The word amorphous came from Greek amorphos, which means no shape. The particles of amorphous solids have only short-range order of arrangements. Regular and periodical arrangement of particles is seen to a short distance only. The structure of amorphous solids are similar to that of liquids. Glass, rubber, plastics, etc. are some of the examples of amorphous solids. Amorphous solids are isotropic in nature. That is to say, physical properties of amorphous solids are same in all directions. In old buildings, it is often seen that glasses of windows get slightly thicker at the bottom. This happens because glasses which is an amorphous solid flows down very slowly. Some very old glasses get milky appearance because of some crystallization. This happens because on heating, glasses get crystallized at some temperature. This is the cause. Amorphous solids are also known as pseudo-solids or supercooled liquids. Characteristics of amorphous solid. Particles of amorphous solids are irregular in shape. Amorphous solids often soften gradually over a range of temperature. Amorphous solids produce pieces of irregular shapes when they are cut into two pieces. Amorphous solids do not have definite heat of fusion. Amorphous solids are isotropic in nature. That is to say, they have some physical properties in all directions. Amorphous solids are not true solids, and hence these are also known as pseudo-solid or supercooled liquid. The arrangement of constituent particles is in short-range order. Amorphous solid example, polymers, glasses. This graph, this figure shows the structure of the amorphous solids. Crystalline solids are classified into 4 types based on the intermolecular forces operating in them. These are molecular solids, ionic solids, metallic solids, covalent solids. So molecular solids, solids having molecules as their constituent particles are called molecular solids. For example, hydrogen, chlorine, water, HCl, carbon dioxide, sucrose, etc. Molecular solids are classified into 3 types on the basis of their bond. Non-polar molecular solids, polar molecular solids, hydrogen bonded molecular solids. So a non-polar molecular solid is solids which are compressed of atoms only, such as helium and argon or molecules, formed because of the non-polar covalent bonds are known as non-polar molecular solids. For example, H2, Cl2, I2, etc. Characteristic of non-polar molecular solids. The molecules of non-polar molecular solids are held together by weak dispersion forces or London forces. Non-polar molecular solids are soft. Non-polar molecular solids are non-conductor of electricity. Non-polar molecular solids have low melting points. Non-polar molecular solids are usually in liquid or gaseous state at the room temperature and pressure. B, polar molecular solids. The solids which are formed by polar covalent bonds are known as polar molecular solids. For example, HCl, SO2, NH3, etc. Characteristics of polar molecular solids. The molecules in polar molecular solids are held together with dipole-dipole interaction. Polar molecular solids are generally soft in nature. Polar molecular solids are non-conductor of electricity. Polar molecular solids have high melting points in comparison to non-polar molecular solids. Most of the polar molecular solids are gases or liquids at room temperature and pressure. Solids SO2 and solid NH3 are some examples of polar molecular solids. C, hydrogen bonded molecular solids. The molecules of hydrogen bonded molecular solids contain polar covalent bonds between hydrogen and oxygen, freon or nitrogen. In solids such as H2O ice, molecules are bound together strongly with hydrogen bond. HF, H2O ice, etc. are the example of hydrogen-bound molecular solids. Characteristics. Hydrogen-bound molecular solids are generally volatile liquid or soft solids at room temperature and pressure. Hydrogen-bound molecular solids are non-conductor of electricity. Solids, ionic solids. Solids in which ions are the constituent particles are called ionic solids. These solids are formed because of three-dimensional arrangement of cations and anions bound together with strong molecular force, for example, NaCl. Characteristics of ionic solids: high melting and boiling points. Non-conductor of electricity in solid state. Conductor of electricity in molten state. Conducted electricity when dissolved in water. Metallic solids. All metals are referred as metallic solids. Their particles are positive ions. These positive ions are surrounded by free-moving electrons. For example, iron, aluminum. Characteristics: high melting point, good conductor of electricity and heat, lustrous and are of specific color, hard but malleable and ductile in nature. Number 4, covalent bonds, solids. Crystalline solids are formed by non-metallic metals because of formation of covalent bonds between the adjacent molecules throughout the crystal. These are also known as network solids. They are also called giant molecules. For example, diamond, graphite, silicon, carbide, etc. Characteristics of covalent solids: they are very hard and brittle except graphite, which is soft. Very high melting point, do not conduct electricity except graphite, also called giant molecules. Thank you very much for listening, and I hope you will learn some information here in this recorded lecture, and thank you again.